Today I'm going to demonstrate to you how to download and run the fractions1 XLSM file. Basically, this is a new file format. The original file that was there was fractions1 XLSX file. The new file format is fractions1 XLSM. It's basically the only difference between the two files is that this one is now macro enabled file, hence the M at the end. So when you download this file, it will now be an XLSM file, a macro enabled file for Office 2010 and Office 2007. So download that file from this video link below from my website, and once you download, have a look at this video demo on what I've done with it. I've made slight changes and I've added a worksheet into the file, and I'll go through with it how to use this worksheet. There's basically the fractions worksheet. It had, as you already know, shaped fractions, right fractions, addition fractions and subtraction fractions. I've currently now added simplified fractions. This will teach you how to cancel fractional parts and simplify them to its simplest form. Now, the worksheet is a printable worksheet, but for the purpose of the demonstration I've also made it an interactive worksheet. But before I show you how to generate the worksheet, let's move to the right hand side where I've got this preset example, which is cancel fractional parts shown below to its lowest form. In other words, simplify this fraction. Now, the way this works is in a tabular format. It seems a bit boring, but it is very good in terms of working this out very quickly and efficiently. Now, the way we should work here is find how many whole parts there are in this fractional form, and we look at our numerator is 32, our denominator is 12. Our numerator is clearly bigger than our denominator, therefore how many 12s go into that number exactly? 32. How many times? And that basically means that we have that many whole number values within this fractional part. So if we say 12 ones are 12, 12 twos are 24, 12 threes are 36, now we've gone above the 32 value, therefore it's 12 twos, two whole number. So 12 twos, which is a whole number value, are 24. Now 24 to 30 is 6, and 30 to 32 is 2. So in effect we've got 8 left over on top. So our numerator now is 8, and our denominator still remains as 12. So 2 whole ones and 8 twelfths is our fraction. Now what we want to do is we can still simplify this 8 twelfths as a fraction. We put our 2 whole ones down, and we have a fractional part which is 8 twelfths, and we want to simplify that even further. In our tabular form we have a numerator, a denominator there, and what we do is we take our numerator, which is 8, and we start with 8, work our way backwards down to 2, 7, 6, 5,
3, 2.
We don't use 1 simply because all numbers are divisible by 1, and therefore we don't need to, as if we do divide these by 1, they will remain the same. Now the method I would employ here is we divide the numerator and the denominator by these numbers here in our first column. Now the idea behind this is simply because we start with the value, the numerator value, simply because it is the highest value that would be acceptable in both cases, the numerator and the denominator. We cannot use the denominator value because the denominator value is now higher than our numerator. Therefore, you won't be able to divide our numerator exactly with a 12, a 11, a 10, or a 9, for example. However, you can divide 8 by 8 exactly once. So what we do is divide our numerator. In the n column is our numerator column, d column is our denominator. We know our numerator is 8. We divide 8 by 8, we get 1. Now we divide our denominator by 8, which is our number there, which we need to divide. Now our denominator is 12 in this case, and we want to divide by 8. We can't divide it exactly, so I'm going to place an X and move on. There's no point in trying to work it out if you can't divide it exactly. So let's do that. This is the manual method, and it's the most efficient method. I will show you how to work in the worksheet next as well. Divide our numerator by 7x. Now if we can't do it by 7, there's no point in dividing. If we can't divide the numerator by 7, there's no point in dividing the denominator, because it needs to divide both the numerator and the denominator exactly. So we might as well place an X and not work this one out either. Again, divide a numerator by 6. We can't divide it by 6. 6 2s are 12. Divide a denominator by 6. We don't necessarily need to work it out, but for the purpose of the demo, I'm going to work this out for you. I can simply put an X and move on, simply because our numerator is an X. But it's 6 2s are 12. I'll place a 2. Let's move on. 5, we have an X, and X again. And 4, we have 4. 4 2s are 8. So if we divide 8 by 4, we get 2. And if we divide 12 by 4, it's 4 3s are 12. Divides exactly. As you can see, we have 2 values that divide exactly. If I continue this, I'm going to continue this for the purpose of the demo, but you can stop this simply because the way this method works is an optimized method. You work backwards with the divisors, and highest divisor being at the top, and then as soon as you find your numerator and denominator dividing exactly by this divisor, you stop. But let's continue onwards and let's see. So divide our numerator by 3, we get X. 3 2s are 6, 3 3s are 9. For the purpose of the demo, divide a denominator by 3 is 4. 4 3s are 12. Now divide it by 2. 4 2s are 8. 6 2s are 12. Now what we can see is we have, I'm just going to put 1 in. Let's divide it by 1. Okay, 1 is basically, if you divide 8 by 1, you get 8. 1s are 8. 12 1s are 12. Just for the purpose of the demo, I've placed these in. As you can see, if we divide it by 1, we have 8 as a numerator and 12 as a denominator, which is what we started with anyway. So it is not necessary to work out 1 in any of the cases ever when you try to simplify using this method. Now, let me just highlight these in red. The 2 values that we have, we can see that our numerator in one case is 2 and the other case is 3, and our numerator is 4 and the other case is 6. Now the simplest form we can see obviously is the one with the lowest numerator and the denominator. As we can see here is 2/3. Now 8/12 in effect cancels down to 2/3. I'm just going to center that. There we go. So I've taken our greatest common divisor between 8 and 12, the numerator and denominator, as 4. And if it's 4, and we found our value, which is our greatest common divisor in both cases, we can drop this line and the divisor 3 line as well. So bottom two lines we can drop straight away. But for the purpose of the demo, I've done this to show you that you can easily find this value straight away if you work using this method, working backwards from 8, which is your numerator value, down to 2. You don't need to put 1 in because it will now that will be the value you started off with. So that is how it works in effect. Now what I'll do in Excel, you can actually work this out using the formula. So let's just try it in Excel. I'm just going to center that, and I'm just going to create a fractional part. Let's get that merged. Page. We can merge the cells. Merge, and I'm just going to center that as well. There we go. Just bring that back. Okay, now in Excel, we'll work this out in Excel in effect. So what we would have in Excel if we wanted to work this out is form is basically to there, bold that in a different color, select that. Now what you'd have 2 whole ones, and we want to simplify 8/12 using the Excel formulas. We can use equals. The 8 we select, and we want to divide that value by the greatest common divisor. It's called the greatest common divisor, returns the greatest common divisor. Now the greatest common divisor of the number 1 value and number 2 value. Number 1 value is E7, and number 2 value is the denominator. The numerator E7 and the denominator E8. So that will give us our numerator, new numerator. The greatest common divisor in effect is 4. So if we work this out using, for the denominator, the same principle, equals, select our denominator, and we want to divide it using our greatest common divisor, which in effect we want E7 comma E8. Now that again gives us 2/3. If I simplify 8/12, I get 2/3. Now that Excel itself is using a greatest common divisor to find your fractional part cancelled down to its lowest form. Now the greatest common divisor in our case is 4, as we worked out here, and our numerator is 2, our denominator is 3. We're working this out as we go along using that same principle that we would do in Excel, but in a tabular format. It's a bit more methodical and a lot more structured. It seems slow, but as you get used to the method, you can work quickly through it. Now if I move to our original fractions 1 XLSM file, let's work through these fractions quickly just to simplify these fractions. We're just going to close that off on the other side because I don't need it and I don't save. Let's go. Basically, because this is interactive, we can work through this very quickly and try and do this. Our numerator in this case is 4, so we start off with 4, 3, 2, Now a numerator is divisible by 4. 4 ones are 4.
1.
Divide our denominator, we cannot exactly divide our denominator. So divide our numerator by 3, you can't. Divide our denominator by 3. 3 3s are 9. Next time I do a numerator, I won't work this
3.
denominator out because I've already got an x. There's no point in working out a denominator and speed things up. Our numerator, now, although I can see it clearly that it's not going to work, but I'm going to work through this particular demo, then I'll explain why I've done this. So divide our numerator by 2. 2 2s are 4. Divide our denominator by 2, and you can't do because it won't divide exactly. In effect, each of these divisors will not work to cancel 4 9s down. So 4 9s will remain as 4 9s.
9.
You cannot simplify that any further. So let's try 3 6. Numerator starts with 3. Let's work this through quickly. 3 and 2. 3 1s are 3, and our denominator is 3 2s are 6. Yeah. So we have that as our half. We don't need to work 2 out because we've had our greatest common divisor as 3. So that is in effect a half. And we've simplified it in one step in that particular case. Let's work through this one quickly. 8 tenths. Let's try 8, 7, 6, 5, 4, 3, 2. Right, 8 1s are 8, won't divide. 7 won't divide, so there's no point in trying the denominator. 6 won't divide the numerator, there's no point in trying the denominator. 5 won't divide the numerator, there's no point in trying the denominator. 4 2s are 8, denominator won't divide. Although I'm aware of this just by looking at it, I think a child must work through this him or herself in order to work this out methodically. So denominator won't divide by 4 exactly. So let's move on to 3. 3 2s are 6, 3 3s are 9. It won't work. There's no point in working denominator out. Now 2, 4 2s are 8, 5 2s are 10.
5.
We have 4 fifths. So 8 tenths cancels down to 4 fifths
5.
in its simplest form. Now 17 sixes. We know our numerator is greater than the denominator. We need to see how many 6s make 17 or near 17. So 6 2s are 12. 6 3s are 18. So 6 2s, 2 whole ones are 12, and 5 6. So can we cancel down 5 6? I'm just going to work through the method quickly, just even though I know our numerator is 5, so 5 4 3 2. 5s into 5 will go once but won't go into 6. 4s into 5 won't go. 3s into 5 won't go, and 2s into 5 won't go. Therefore that is its simplest form, and that's the quick check. Regardless of whether you see it as it's in its simplest form or not, my advice to a child would be to work through this very quickly. It doesn't take more than 5 seconds to work through the method. If you work through it and apply the method, you would have worked to its lowest and its simplest form. So try to apply the method regardless. Build your speed up quickly and efficiently in the tabular format. Again, 7 19ths. Let's work through it. You got 7 6 5 4 3 2. Now, one of these things that I should mention here is, in effect, let's have, I have a a worksheet which I call prime numbers, which is already on my website. Now it is a very good worksheet, and it's worth a look at. So if you were to bring prime numbers in, I'm just going to show you why you need that. I'm just going to put side by side the prime numbers. We can see our denominator as 19, our numerator as 7. Both 7 and 19 are prime numbers. On the right hand side I've got basically the numbers that are not highlighted between 1 and 102 are all prime numbers. 2, 3, 5, 7, 11, 13, 17 and 19. Because 7 and 19, our numerator and our denominator, are both prime numbers, they're only divisible by 1 and itself. So in effect, if you know your numerator and denominator are prime numbers, you can ignore the method and know that you already have the simplest form in itself. So there is no point in trying the tabular format any further. Now here in this particular case, I have 11 as my numerator, which is a prime number. However, my denominator is not a prime number, it's 16, it's in red there. But because my numerator is a prime number, the only number my numerator is divisible by is 11, no other number. Now 16 I know is not divisible by 11 exactly, so that again is in its lowest form. So apply your prime numbers knowledge to work quickly and efficiently. Again, if you had to work it out,
11.
It's basically 11, 10.
10.
You don't need to do 10 simply because 11 will only go into itself once,
1.
as it's a prime, and denominator 16 won't be is not divisible by 11. So x is not exactly divisible by 11. So we put an x in effect, forcing us to put 11 16th as 11 16ths, and it cannot be cancelled any further. So let's work through example 7 and 8. 17, 25 17ths, okay. 17 twos are 34, so we have 17 ones are 17, so 1 whole 1. And 17 to 20 is 3, 20 to 25 is 5, 5 and 3 is 8. We have 8 17ths.
17.
Now in this particular case, our denominator is 17, and 17 again we know is a prime number, and as we know 17 is a prime number, it is only divisible by itself and 1. Now because we don't divide by 1 and we don't divide by 17 in this case, because we start off with 8 and we go down to 2, and we know the 1 and 17, we never come across those two numbers for our numerator. In this case, that is the simplest form as well. So let's move further on. 7 and 7. 7 goes into 7 once, which means it's 1 whole 1, and then no fractional part, and that is in its simplest form as well, as 1 whole 1. That is basically the worksheet. As you can see, I'll work through this pretty quickly, but for the purpose of the demo, I've tried to cover as much ground as possible, including how to apply your prime numbers knowledge to simplifying fractions in its lowest form, and how to use this tabular format method, which will consistently give you the correct answer if you follow the method all the time. Now the way this worksheet works is basically, I'm just going to clear this content first of all. So if I clear what I've done, and then generate the worksheet again, I'll show you how the worksheet is meant to be used. This is how you're meant to use it to work through the worksheet and work through the method. But to generate the worksheet is slightly different, and I'm just going to cover that as well very quickly just before the demonstration ends. So one of those cells is locked, that's all it's saying. So just clear those content. Let's clear that and clear that. Okay, could have multi-selected and cleared it all, but that will do. I've cleared everything. Now that's the worksheet. I'm just going to close off my primes worksheet. The prime numbers worksheet exists on my website, and I have to generate the first few primes is also explained in the video on my YouTube channel. Have a look at it and how to work these prime numbers out very quickly and efficiently in less than a minute or so, basically. So have a look at that. The approach that you use is this particular approach, and it is very quick and efficient to locate all the primes. Let's close the prime numbers worksheet now, and I'm going to use all the real estate on the desktop. There we go. So now to generate the worksheet, we have this generate sheet at the top near the and just below the fractions heading. It currently says false, so it doesn't allow this worksheet to be generated whilst I'm typing. If I set it to true, as you can see, all the fractional parts did change and got updated. Now if I press F9, it will generate the new worksheet every time. Keep pressing F9, it will generate as much as possible. Once this is generated and you want to print it, you basically go to File, Print, and you'll see the worksheet, and it'll print that worksheet, and you can set it off as homework. However, if you want to work through it interactively, all you have to do is, once you've generated the worksheet, you need to set it back to false, so when you type values in, it doesn't change any of the values. As you can see, I've typed it in there. Now if I change it to true, it changes these values. Now if I type a value in and move off, it changes again. Do you see? So in effect, for you to work through this worksheet interactively, what you'll have to do in Excel is to turn generate sheet to false, and then work through the interactive worksheet. That will guarantee that it will not change the values that have been selected, your fractional values. So have a look at the video, have a look at my website, download all the necessary bits that you need for fractions, and enjoy. Try the method, apply the method, work through the method. It does always guarantee results, and it guarantees the correct results all the time. It seems slightly slow to begin with, but you can literally work through it very quickly and effectively. So enjoy. If you do like the video, please click like on my YouTube channel, or Facebook like it, or Google Plus want it. Okay, cheers.